Today we're going to be talking about interpreting place values. As we discussed last time, a value means that each place that you have is represented as a value if there is a digit occupying its place. For example, if we have 6 ones, that would mean that the value of the digit 6 in the ones place is the same as saying that we have 6 ones, which means it is equal to the number 6. If you would like some more information, please view the Understanding Place Values video. Interpreting these place values means that each value holds a different amount depending on the place that it is in. The farther left the place is, the more value it has. For example, if I have a 2 in the tens place, that means it is worth a total of 2 in the tens place being 20. However, if I put a 2 in the millions place, this would mean that I have 2 of the amount of millions in that number, which means the value is 2 million. As you know, I'm sure, 2 million is greater than 20 million. So if I had $2 million, you would much rather have that because it is greater than 20. Now, the farther to the right that you go, the less value it has. Take, for example, I have 2 in the 10,000s place and 2 in the thousands place. This would mean that I have 2 of the amount of 10,000s and I have a 2 in the thousands. If you were to ask which one is greater, you would know that 20,000 is greater than 2,000. So that means the farther right we go, the lesser values all the numbers are going to be. So the place that's on the left is going to be always 10 times the value of the place to its right. For example, if I had a 1 in the hundreds place and a 1 in the tens place, this 100 is 10 times the amount of that tens place. Take, for example, if I had 100 and then I write the number 10 just below it, this would be 10 times greater than the 10 that I have. However, in its opposition, to the right means that it's going to be less. So, if I'm looking at that place here on the left, meaning if I had a 3 in the tens and a 3 in the ones, I know that the ones place on that tens left is going to be 1/10 that value of the 10. So to write that out, if I had a 3 in the tens and a 3 in the ones, the 3 in the ones place is 1/10 the value of the 3 in the tens, because the ones place is less than the tens place by 1/10 the amount. In contrast, I could write it the opposite way by saying the 3 in the tens place is 10 times the amount of the 3 in the ones, because the tens place is 10 times greater than the ones place. This trick, this understanding will work on any place value you have. Because the thousands place is 10 times the value of the hundreds place, and the hundreds place is 10 times the value of the tens, and the tens place is 10 times the ones, every time we go to the left, the value increases. For every place that is to the left of that number, that place is 10 times the value of the previous one. However, we can go backwards with this as well. And we can break down this ones cube into another cube that could be 1,000 pieces into it. And this is how we're able to demonstrate that tenths and hundreds are less than 1. If we continue to break that down, we can see that the tenths is just going to be one slice of that entire cube, because that would be a tenth of the entire cube. When we look at a tenth of the entire cube, we are only looking at those each individual rods, every little column that is inside of there. When we're looking at every column, there's one cube inside of those tenths, which would mean that the one cube that is inside of 1/10 is less than the entire tenth rod, which would make it hundredths. We can also see it represented this way. We're only going to be looking at one rod at a time. And out of that one rod, we're just going to be looking at just that one cube at the top. Then we will be able to see the values can still increase and decrease as we continue, now that we know that we do have tenths and hundredths. Take these practice problems. I want to compare the number 2 and the number 20. So I'm going to write 2 in the ones, and I'm going to write a 20 for the tens. If I wanted to compare these two, I would say two different ways. The 2 in the ones place is 1/10 the value of the 2 in the tens place. However, I could also say that the 2 in the tens place is 10 times the amount of the value of 2 in the ones place. If I were to look at 11 and 110, if I see 11 and then I also see 110, there are multiple ones that I can compare. We could do this one, for example. I can see the 1 in the hundreds place would be 10 times the amount of the 1 in the tens place. I could also say that the 1 in the tens place is 1/10 the value in that tens place as the 1/10 the value of the 1 in the hundreds place. I can also do this number, 2 and 24 hundredths. I can compare the 2 in the tenths is 1/10 the value of the 2 in the ones. Similarly, I can do 2 is 10 times the amount of the 2 in the tens. If I have 3 and 77 hundredths, I can also compare it with the 7 tenths is 10 times the value of the 7 in the hundredths. In contrast, I can say the 7 in the hundredths is 1/10 the value of the 7 in the tenths. As a decimal, it would look no different. The 7 in the hundredths is 1/10 the value of the 7 in the tenths, and the 7 in the tenths is 10 times the value of the 7 in the hundredths. If you try the number 2,222, you can compare many numbers. I can say the thousands is 10 times the amount of the hundreds. The hundreds is also 10 times the amount of the tens. And I can say the tens is 10 times the amount of the ones. I can also say that the 2 in the ones is 1/10 the value of the 2 in the tens. I can also say the 2 in the tens is 1/10 the value of the 2 in the hundreds, I can also say that the 2 in the hundreds is 1/10 the value of the 2 in the thousands. Let's take some practice problems. A store sold 2,222 items in one day. Which statements about this number are true? When we look at this, it says the value of the digit in the tens place is 1/10 the value of the digit in the hundreds place. If we look at the 2 that is in the hundreds place and the 2 that's in the tens place, we see that they are the same, and our main focus is not so much the digit as much as knowing if the place itself makes sense with the value we're comparing. So from now on, let's just look, since all the digits will be the same in this number, solely at the value that we're comparing these two places to be. Again, is the tens place 1/10 the value of the hundreds place? Meaning that is the tens place less than the hundreds place by 10 times the amount? The answer would be yes. Because if I were to compare that with 100, I can see that this hundreds place, I should have written this as, there, that might help us. This tens place is less than the hundreds place, which means the tens place is 1/10 of the value of the hundreds. So that one would be correct. The value of the digit in the hundreds place is 10 times the value of the digit in the thousands place. If we look at this number, do I see that the hundreds place is 10 times greater than the thousands place? We would say no, because the hundreds place should be 1/10. So that one is wrong, while this one is right. The value of the digit in the thousands place is 10 times, meaning greater, than the value of the hundreds place. We know that the thousands is worth more than the hundreds place. And because the thousands is right next to it, we know it's 10 times a difference. That means that the thousands place is in fact 10 times greater than the hundreds. That is correct. The value of the digit in the hundreds place is 1/10, meaning less than the tens place. Because we know the hundreds place is greater than the tens place, we know this to be wrong, as 1/10 is less than. The value of the digit in the ones place is 10 times, meaning greater, the digit in the tens. We know that the ones is actually 1/10 of the tens, so this one is wrong. So when it says choose two answers, you would choose the first one, and you would choose the third one. A stadium sold 33,300 tickets to a concert. Which statement about this number is true? Notice how we have the same digits again. They're repeated. So let's just take for a moment the places they are in and see if it's compared with 10 times the amount or 1/10 the amount. Is the digit in the tens place 10 times, meaning greater, the value of the digit in the hundreds? Since the tens place is 0 and the hundreds place is 3, we know that 10 times 10 does not equal 300. Therefore, A is wrong for that reason. However, we can also look at it this way. Even if you didn't notice that the 3 is in the hundreds but a 0 is in the tens, read this problem again and see if you could find the solution without any digits. The value of the digit in the tens place is 10 times greater the value of the hundreds. We know that the tens place must be 1/10 of the hundreds. So either way, this answer choice is wrong. The value of the digit in the thousands place is 1/10 the value of the digit in the 10,000s place. So we do have the 10,000s place that is greater than the thousands place. Therefore, the value of the digit in the thousands place is less than the 10,000s place, so that is true. Keeping on to check our work, the value of the digit in the hundreds place is 10 times greater than the value of the digit in the thousands place. We know that the hundreds is actually less than 1,000, and so the answer should be 1/10, but it's not. So C is incorrect. And the value of the digit in the 10,000s place is less than the value of the digit in the hundreds. We all know that $10,000 is, of course, not a tenth of a mere $100. So this one is wrong as well. If the number shown has a 7 and a 7, both represented as a 10,000s and a thousands, the digit underlined, we know, is the thousands. And the 10,000s is 10 times that amount. So which statement is true about the circled digit? So when you're reading this problem, our huge focus is placed upon the circled digit. Is that circled digit, that value, 10 times greater than the underlined digit? Meaning, is 7,000 10 times the amount of 70,000? Since 7,000 is less than 70,000, we know that this should say 1/10. Therefore, it's wrong. Is the thousands place 1/10 the value of the underlined 10,000s place? So that would mean, is 7,000 1/10 the value of 70,000? The answer is yes, it is. 7,000 is 10 times smaller, less than, which would mean it's 1/10 the amount of 70,000. If we look at the rest of the answers, it's focusing on 70 because it's thinking because it's a 70 and a 7, you're going to choose that. However, we know that 70 times 7, if we check that, the answer should have a 49 somewhere in that problem. Take, for example, the value of that 7,000 70 times, meaning it would need to be 7,070 times, but that would have to be 490,000 if you were to try it 70 times. Because the 4 and the 9 are non-existent in our number, we know that it's just trying to confuse us, and therefore anything that you go backwards or forwards on would be wrong. So therefore, our answer is B. If you need to replay this video to make sure that you understand today's lesson, you may do so. If not, please continue practicing, and I will see you next time. Bye-bye now.